Hello, my name is Haley Romero and my group is Food Microbiology. I'm very interested in the overall health of humans and believe that a main contributor to good health is diet. People should be aware of what's going into their bodies, and this is just at a microscopic level. My topic is going to be about the role of bacterial biofilm in antibiotic resistance and food contamination. What it is. The definition of biofilm is microbial groups or communities that attach to living and non-living surfaces, and they're often found in natural, medical, industrial, and food environments. I'm mainly going to explain how biofilms directly and indirectly affect the foods that we consume and how they affect the industries that produce them. Even though I'm going to be talking about food, it's important to just remember how biofilms can affect medical environments because this is how a lot of complications and infections can occur after surgeries. But anyways, bacterial biofilms are extremely difficult to get rid of once they're securely attached at an irreversible attachment stage. Microorganisms inside of a biofilm are enclosed in a matrix of extracellular polymeric substances. This acts as a very protective barrier that keeps microorganisms safe against hostile conditions such as antibiotics, sanitizers, and other related conditions. It also makes it a lot easier for food contamination and foodborne illness. Once the formation of biofilm passes its infant stage, it seems almost impossible to get rid of. The biofilm is very hydrating and microorganisms grow very well in it. Different types of microbial cells grow very close together in order to have a cell-to-cell communication process. These microbial cells begin to work together as a community, and they can even pass virulent factors to each other through secretion. And to me, it reminded me of synapses in humans, like how neurons are placed very, very close together for a quick and effective cell-to-cell communication process. They are also very resistant. Biofilms create an extremely resistant environment, and it's fascinating how adaptable and protected they are. Bacteria that live in these biofilms are at an advantage. The matrix protects the microorganisms from harsh conditions such as antibiotics, chemical biocides, host immune responses, and UV light. Some harsh environmental conditions would include a high temperature, high pH, high pressure, high salinity, and poor nutrients. It's not everything that can support poor nutrients, but I think that this matrix does a very good job in keeping the microorganisms very resistant. The structure and protection that the biofilm gives the microorganisms is a factor in the ongoing dilemma of antibiotic resistance. If sanitation is not kept thoroughly from the start of the industry, then these biofilms pose a threat to the food businesses as well as human health. Because these biofilms are so resistant, they become a source of cross-contamination and foodborne illness. So this directly affects human health. If we can't find a way to get rid of certain harmful bacteria, then cross-contamination and foodborne illnesses will continue to rise. A source from my paper states, currently, it is believed over 80% of chronic infectious diseases are mediated by biofilms. It is known that conventional antibiotic medications are inadequate at eradicating these biofilm-mediated infections. And this specific quote stood out to me because it showed how resistant biofilms are to antibiotic medications. And that makes it very difficult for places like the food industry to keep up with sanitation. With antibiotic resistance on the rise, these biofilms create the perfect environment for passing virulent factors to unsuspecting consumers. It is important to be aware of what's in your food and about what it is exactly that's causing it. It may not be wise to try and create another antibiotic to kill this extremely resilient one because it may just become immune to something even stronger. Some theories on how to eradicate these biofilms are: number one, stop the biofilm production at an infant stage. If you stop it early, then you can kill it before it reaches that irreversible attachment stage, and then you won't have to worry about the contamination. Another theory of how to get rid of this is interfering with the cell-to-cell communication. It is believed that if one can interfere with the organism's communication system, then they will likely fall apart and will no longer be as efficient. And then here are two images. You can see the different stages in the first one. It shows an irreversible or reversible attachment, and then slowly in the next step there is a microcolony formation, and then there's the maturation where they start having that really close cell-to-cell communication, probably passing some virulent factors, and then last is dispersion. And as you can see, it goes back to the start, which shows that this is a cyclical process. And then in the next image, it shows antibiotics being put into the matrix, and you can see how it slowly disperses to almost nothing. So, biofilm development. Biofilms are encased in an extracellular polymeric substance matrix which acts like a barrier. This barrier keeps the microbes protected from harsh substances such as sanitizers, antibiotics, by blocking their entry. Bacterial cell growth is slow, but it creates resistant cells that have the ability to survive in unfavorable conditions. Biofilm formation begins with a layer of polymeric substances in which microbial cells swarm the superficial layer of growth in the biofilm. This is the irreversible attachment stage. Next is the microcolony formation stage, like how I was talking about in the last slide, where microcolonies are described as basic units of biofilm and are compartmentalized by channels with different distinct microenvironments. Cells have already been firmly attached at this point and begin to secrete polymeric substances which act as a type of glue. And then it also has the steps written here where you have the attachment, the formation, the maturation, and dispersion. And then, as I said before, it works cyclical-like. It just goes in a circle. Here is the other graph where it shows the growth and fluorescence. I was having a hard time finding a graph that would tie into this, but this just showed the biofilm growth, and it shows that the green fluorescence was higher than the red fluorescence. And then in food industries, food processing settings are the perfect place for microbial attachment and biofilm formation because they can get nutrients and hide in small grooves or crevices. This biofilm that grows on food processing machines can pose a food and safety risk. It is also stated that poor sanitation of food contact surfaces, equipment, and processing environments has been a contributing factor in foodborne illness outbreaks, especially those involving Listeria monocytes and Salmonella. Ineffective cleaning and sanitation can leave food residues to remain and facilitate the growth and formation of even more virulent bacteria. The biofilm is difficult to eliminate and can therefore contaminate any food easily. If the factory finds out that their food is contaminated, then this could lead to much food waste as well as a very big monetary loss for the company. If there can be a way to stop the formation of biofilm production at an early stage, then companies can be more confident in their product and they won't have to worry about an economic loss. Microbial film is linked to food spoilage and contains disease-causing bacteria which can damage the product or even harm the person who is ingesting it. And this is also just talking about how bacteria can stick to the equipment. I read that it can happen fairly often in dairy industries, so with like milk, and it also happens with meats, obviously. If the equipment is contaminated, then the unknowing company will continually release its corrupted products to the public. This cycle of harmful biofilm formation can lead to economic losses and create more problems with foodborne illness. This is a problem with health, hygiene, and sanitation to the public. Biofilms are difficult to eradicate once they have an irreversible attachment and mature, so it is imperative to take care of while the biofilm is still at an early stage. And there's the works cited. Thank you for listening. Have a nice day.